So this video is gonna be for the trigonometry homework. I already did questions 1 and 2 in the other one, so I'm just gonna be doing questions 3 to 8 in this one. So football is launched at a certain angle above the horizontal. Okay, so it's launched at an angle right above the horizontal. So the horizontal is this x-axis right here, right? This is your horizontal. That's your horizontal, and so there's an angle right there. There's an angle right there. Now, the velocity of the football in the y direction is 10 meters per second. So your velocity in the y direction is 10 meters per second. The velocity in that football in the x direction, is 7 meters per second. And that's your initial. And these are initial velocities. So the question then tells you, well, what is the angle the football is launched at? So we want to find out what our angle is. So I made this a bit larger. We want to find out what our angle is. Well, we know what's adjacent to our angle. Adjacent to our angle is 7, right? This is adjacent. This side is adjacent to our angle. It's right next to it. We know what the opposite as well. Our opposite is 10. Our opposite is 10 meters per second. So I'm just going to write 10. So we have these three things, right? We don't know our hypotenuse, so there's only one equation we can use. There's only one equation we can use. The only equation we can use is tan data is equal to opposite over adjacent, right? We have our angle, we have opposite, and we have adjacent. These are the only things we have. So we're going to plug in everything. So we're going to do tan data is opposite, which is 10, and adjacent, which is 7. And so now you're going to go to your calculator, right? Because before that we have to. So in math, your teacher told you to do data is equal to tan -1. Right, and that's exactly what I'm going to tell you too. So you're going to do tan -1 because you want to do the inverse of tan. When you're moving the tan to the other side, you have to do tan -1. So now you go back to your calculator. So you do whatever calculator you use. And now you're going to do inverse tan -1. Make sure you switch the degrees. And then you do 10 divided by 7. And close your parentheses. Then you get 55 degrees. Perfect. So our data is 55 degrees. And that's the angle the ball was launched at. So now let us do number 4. I wish it wouldn't do that sound. Actually, I know why it does that sound. So let's do number 4 now. Again, we're going to draw a triangle. So a child kicks a ball with an initial velocity of 10 meters per second at an angle of 35 degrees. So you know the child kicks the angle at an angle of 35 degrees. So you know that's the angle. So angle 35 degrees with the horizontal. So that's our 35 degrees. And we know that he kicks it with an initial velocity of 10 meters per second at that angle. So we know that's your hypotenuse. The ball goes upward and to the right at an angle of 10 meters per second above the horizontal. And the question is asking you, well, they want you to find out, well, what is the initial vertical velocity the ball was launched at? So what is VYI, right? So what is your initial vertical velocity? Because y is your y direction. So you know 3 things here. So you know your angle is 35 degrees. You don't know what's adjacent to your angle because you don't have nothing next to your angle. You know what's opposite your angle. Opposite of your angle is what you're trying to find out. And your hypotenuse is 10. So now what you're going to do is you're going to figure out, well, which formula has all of these things with, right? Which one of those three formulas has everything you need here? And so, well, you're going to do sine theta is equal to opposite over hypotenuse. Then you're going to do sine 35 is equal to VYI over 10. So you multiply this by 10, right? Because you want to get rid of that 10. So then you're left with 10 sine 35 is equal to VYI. And then you're going to plug it into your calculator. 10, make sure it's in degrees. Sine, what am I signing? 35. So sine 35, and then you get 5.74, somewhere around there. Actually, I'm just going to write 5.7. 5.7 meters per second. So that's your initial vertical velocity. Let's do a new one. Let's do number 5. So, next problem. So a baseball is thrown at an angle of 30 degrees above the horizontal. So, draw a triangle again. 30 degrees above the horizontal, right? Above it, right above it. Right on top of the horizontal. The horizontal component of the baseball's initial velocity is 15 meters per second. So your initial velocity in the x direction, right? Because that's your horizontal component. It says horizontal. So the horizontal component of the baseball's initial velocity is 15 meters per second. And the question that is asking you, well, what is the magnitude of the ball's initial velocity? So what is this initial velocity right here? They're not asking you the vertical velocity. They're asking you what the initial velocity is, what the total velocity is. They're not asking vertical. They're asking initial. They want to find out what your hypotenuse is. So, which one of these do we know? Well, we know what angle is, right? So we know what angle is. So we know our angle is 30 degrees. We know what's adjacent to our angle. Adjacent is the horizontal right here. That's 15. We don't know what opposite is. Hypotenuse, we know what, well, we want to find out what our hypotenuse is, right? We want to know what our VI is. So we're going to choose a formula to use. The only formula you can use because of everything you need, right? Because you have adjacent and you have hypotenuse. So you have your angle, adjacent, and hypotenuse. You can now start solving for it. So you have 15. Your hypotenuse is VI. So you want to multiply by V on both sides. And now you're left with VI cosine 30 is equal to 15. You're going to divide by cosine 30, right? Because you want VI by itself. Divide by cosine 30. Again, you want, we brought the VI over from this side to the other side. Now we want to get VI by itself again, and we want to divide cosine 30. So VI is 15 divided by cosine 30. 15 divided by cosine 30. I mean, I just plug into a calculator. (15 divided by cosine 30). Make sure it's in degrees, and we get 17.3. So our initial velocity is 17.3 meters per second. So a golf ball is propelled with an initial velocity of 30 meters per second at an angle of 47 degrees above the horizontal. So you have a triangle again. 47 degrees. And you know your initial golf ball's initial velocity is. Oh, you want to find out what your horizontal velocity is. So you want to find out that. And so your total velocity, wait, hold on. It says here in the beginning, a golf ball is propelled with an initial velocity of 30 meters per second above the horizontal, at 47 degrees above the horizontal. And it says your horizontal component. Your horizontal component is what, right? That's what they want to find out. What is your horizontal component? So here we have theta is 47 degrees. Adjacent is Vxi, right? So that's Vx. We don't know what's opposite. And we have our hypotenuse. It's 30. So which formula has everything we need here? Or everything we have? Well, cosine does. Cosine has theta. Cosine has adjacent. And cosine has hypotenuse. So we're going to continue writing this. So cosine 47 is equal to Vxi over 30. Multiply by 30 on both sides. And we're going to plug this into a calculator. So 30 cosine 47. 30 cosine 47. Close my parentheses. And we have 20.5. So we have 20.5 here. So 20, I'm just going to write it as 20 meters per second. And so that's your horizontal velocity. So number 7. A projectile is fired with an initial velocity of 140 meters per second at an angle theta above the horizontal. So initial velocity 140 meters per second. I'm not going to color that red. At an angle above the horizontal. So at some angle above the horizontal, and we know that our initial velocity is 140 meters per second at an angle above the horizontal, 140 meters per second. If the projectile's initial horizontal speed is 60 meters per second, so 60 meters per second, that's our horizontal speed, then the angle theta measures approximately what? Right, this is the same problem as the last problem, right? We have our angle. I mean, our angle is something we want to find, right? So angle is something we want to find. Adjacent is our Vx, which is 60. We don't know what opposite is. Our hypotenuse is 140. And then we're going to use cosine again. Theta is equal to adjacent over hypotenuse. Cosine theta is equal to adjacent, which is 60. And hypotenuse is 40. So usually teachers, again, the math teachers tell you just do, when you move the cosine to the other side, you have to inverse it. So you do cosine negative 1. 60 divided by 140. So you have theta, 60 divided by 140. So I'm going to do inverse cosine negative 1, 60 divided by 140. You get 64.6. 64.6. And theta is 64.6 degrees. That's the angle. All right, let's move on to 8. Say here a ball is kicked, again at an angle of 30 degrees above the horizontal. So you know your angle is 30 degrees. 30 degrees. The ball has an initial velocity. It doesn't really look like a right triangle, but just believe me, that's a right triangle. The ball has an initial velocity of 5 meters per second. So your initial velocity here is 5 meters per second. What is the magnitude of the horizontal component? So they want to know what Vx is. They want to know what Vx is. Now, we know our angle. Angle is 30 degrees. Our adjacent to our angle, right next to our angle, is Vx. And that's what we want to find out. We don't know what's opposite. And our hypotenuse is 5. So again, the only formula with all three of these is cosine. So cosine 30 is equal to Vx divided by 5. Oh wait, no. Vx, no. Yeah. Vx divided by 5. And so you multiply both sides by 5. And now you just plug this into a calculator. So you're going to do 5 cosine 30. And then you get 4.33. 4.33 meters per second. That's your horizontal velocity. Now, that's it.